started removing element, right? So we added element to the last, and the next is going to be removing element into the beginning of the list. We're going to do the same thing. Now we're going to go add, create a method, and we're going to call this one remove first. So since it's, it's going to remove the very first no matter what, so it's going to check that if we have something in the list, and if the first pointing to something, we're going to remove it. So let's see what happened. I'm going to go back to, the only problem I have is that anytime I go back to whiteboard, whatever we had previously is going to, so we have to do it again. So imagine we have already some nodes in this list. Let's start with the 3 again. I have my first and last pointer. So I'm referring to the very first one, and this one referring to the last one, and they are pointing to each other, right? So we have this scenario, and we want to remove the first one. So the only thing I have to do really is that to go to the very first and tell the first node, the reference to the first, that is no longer going to be your first, and the first dot next now is going to be your first, right? That's the only change we have to do. And so since nobody pointing to this first node anymore, right, again, garbage collector is going to collect that as well, right? So we don't have to do anything else. That's the only change we have to do in order to remove a very first element from our linked list. So again, that's very fast, order of 1. So now again, if I want to now remove this one from the linked list, just then we keep going to see what happened, like, until we get to the no element in this linked list. So if I remove this one from the linked list, I have to do the same thing, right? I have to just tell that the first that this no longer is your basically your first one, and you have to point to this new one, and so that one also going to be removed from the linked list. So I don't have to maintain anything else. But if I have only one element in this list, as you can see, first and last, they both pointing to that element. So if I tell the first that, just point to the first dot next, which is automatically null because, first dot next is null. Same code, if we repeat that, it's going to be working because this one is going to get out of a basically list, and our first become null. But then we have to also maintaining the last, because as you can see, the last is still pointing to that single node. So if we don't maintain that one and the last is still pointing to it, that means we didn't really remove it from the list. And so garbage collector also is not going to remove it. So we have to also maintain the first, the last and first, right? So basically we have to check. And if we notice that our list is either empty or only have one single element in it that we're trying to remove, we have to make sure the first and last are both pointing to null. Otherwise, we didn't remove it. Of course, if this list is already empty, right, then we don't even have to remove anything. There's nothing in the list. So that's exactly what we're going to go and implement. And that also, as you can see, it's for us is order of 1, right? So we really have to go to our last and telling, check that changing the value of it to its next one. Sorry, I said last first. I have to check in the value of it to the next one. So that's the only change that we have to do. Let's go back to our code. And we're going to start implementing. Since we already have this method that telling us if the linked list is empty or not, I'm going to use that. So if the list is not empty, right? Because if it's empty, I can just tell the user that, this list is empty and I cannot really remove anything from the list, right? So that's what we can tell a message to the user that this list is already empty. So they know that we can't really remove anything. But if it's not empty, that means we at least have one element in this list. So how I know that I only have one element in the list? So I already know the list should not be empty, right? Because we have this is empty. How we know that only we have one element in this list? Exactly, right? So if first and last was pointing to the same place and they're equal to each other, then we know that was the only element in this list. That's why the first and last value are the same. So that's what we're going to do exactly, right? So if the first and last are the same, that means that this value that we're trying to, first of all, we know it's not empty, so they're the same, but they're not null. So we have only one element in this list, and that element is the one that we're trying to remove it. So that means we have to now make sure that they're both going to be pointing to the null, right? So I can tell that the first okay, equal to last, and they're both going to be equal to null. So that means we only have one element in this list, and we remove that, and we're making sure that we maintain the value of first and last. But if that's not the only element in the list, I mean, we have more elements in this list. So the only thing we have to do is to have to tell the first that you need to point to first dot next. Anything else we have to do? Are we missing anything? Look at our code. I think there's something that we missed. We added the size, right? So we need to maintain the value of size. Now we removed one element from this list. We have to make sure that we decrement the value of this as well. So here I have to make sure that do you have any question? Is that what you were trying to say? That you raised your hand? Okay. What else we can do here? It would be nice to, tell the user which element actually got removed from this list. So I'm just going to add in, a little bit of a extra code here. Since the elements are basically a string, so I can do, and we know that's the first one that's going to be removed. So I can store the value of the element that we stored in the very first node into a temporary place. So after we remove them, we make sure we remove it and we decrement the value and everything is good. And then we can now tell the user that that particular element that we store in our temporary location is removed. Any question? Anybody? Everything is clear for everyone? So that was also order of one, as you noticed, right? So we didn't have to do anything more than just copying one address, single address. So the next thing we're going to do now is see how we can now remove element from the end of the list. So next method is going to be the remove last, and see how that one works. Is that as easy as what we did by removing element? So let's do the same kind of analysis on this one. Again, I'm going to just creating a 3-node linked list. First, and last, and then we're going to have the reference and so on, right? So okay, so now I'm trying to remove element from the last. So basically, this is the node I'm trying to remove it. So I know the last is pointing to it. So I just have to go tell the last, exactly what we did from the previous one. I have to go to the last and tell the last that you don't have to point to this one anymore. And you have to actually go ahead and point to the one behind it, right, the previous node. But how am I going to find this one? That's the only way, right? We have to basically traverse the entire linked list, because this is a singular linked list and I only have reference to the next. I don't have any reference to the previous node. So there's no way for me to figure out who is the previous node to this last one. The only way for me to identify that is traversing this entire linked list from the beginning of this node, right? So from the beginning. So I'm going to start from the first, and then I keep going until I notice that whatever node I have, the next is actually equal to the last. And so then I know this is the one that I was looking for it. And then I have to switch the address to that one. So imagine I have n element in this list, right? If this is a large list and I have n elements in this list, I'm trying to show that this is like a large list. So if I have n elements in this list, right, and I'm trying to remove the very last one, in order to find an element, which is like element at position n, for example. So I'm trying to find the n-1 node so I can basically make the changes. So how many nodes do I have to traverse in order to get to that point, you think? I have n nodes and I'm looking for n-1. How many nodes I have to go until to get to the n-1 node? Almost n-1 traversing, right? So that means this is going to take us order of 1, because, order of n, right? Because there's no way that I can just copy the address. I have to go away to find the address first, then I can copy the address. In this traversing, it's going to be linear traversing. As much as I have nodes in this list, I have to keep going. As if I increase the value of the nodes, the number of the nodes, I basically have to increase the number of time or the number of traverse to get to that point. And that means I have to basically spend more time. And that's the complexity, right? So the complexity of this is going to be no longer order of 1. It's actually going to be order of n. And that's, again, because we have to do at least, if you have n nodes, again, all big O notations are worst case scenarios, right? And that when you really have a large number of elements in this list. So if I have really n element in the list, then that's going to take me order of n. But then when I find it, then it's going to be really easy just to copy the address of it. But we have to first find it. So let's write a code for it now again. So although also another thing that we have to do, like what we did previously, if only one element in the list, and that means first and last is pointing to the same place, and so we have to maintain the value of them. So that's pretty much similar to what we did in the remove last. But again, the only problem here, I have to first traverse all the way, traversing the entire list to get to that point. So how I'm going to do that? So in order to get the traversing here, so of course, if the list is not empty, oops, what I did. And if it's empty, it's going to be similar to what I had there, right? So the list is empty, so I'm not going to think. But if it's not empty, and then we have, again, going to these different scenarios that we have. So the first scenario can be like what we did previously. If it's the only element in this list, and I know if last and first they're both pointing to each other or the same place, that means that's the only element into the list. So again, we're going to do the same thing, right? So basically the value of first is equal to last, and is equal to that is the one of what we know. But otherwise, then this traversing is needed, right? So now we have to do the traversing. How are we going to do that? So again, the only place that we can start is going to be the beginning of our node. So we can basically have a temporary location or a place, or we can also call it a runner that to keep going until it's find a location of the nodes right behind our last. So I'm going to call this previous, right? Really, just because that's basically we're looking for that previous node. But we have to start from the first. So the value of my node, and that's going to be the type of my node, right? Because again, we're keeping the reference of this previous node. We need to know the address of it. So the original one, basically the beginning of it is going to be my first. Right? That's the place I'm going to start checking. And as I do, I need to basically have like a loop, right? And we're going to keep going, and then we keep moving. And if it's not the one, if whatever I'm looking at it right now is not the one, then I have to go to the next, right? So basically our previous always going to be the previous dot next. That's how we're traversing into this linked list, right? So the condition is I have to check that if the previous dot next is equal to null, right? If if the previous dot next is equal to null, what does that mean? Sorry, to last. I said no. If the previous dot next is equal to last, that means I have to stop, right? That means I find the basically the previous element. That's my previous element that I'm looking for it, right? But if it's not, right, that's the one that I have to start keep looking. And for keep looking, that means I have to keep going to the next element. So that means my previous dot, my previous basically is going to be my previous dot next. So the next round that I come up here, my previous now is basically one, we're moving to the next node. And so we're checking the next of that node. And if it's last, that means now I find it. If not, then I have to keep going. So that's why this is a loop that can potentially take us order of n if you have n element in this list in worst case scenario. And this is how we really traversing the list. We need a runner, we need extra reference. We cannot mess up the value of the first, right? Because we keep wanting to go to first dot next. So if I just use the value first, then I'm going to basically override it by next and next and next. So I'm then basically going to lose the value of the very first one. So I need to have a temporary location, and then I'm using that temporary location in order to keep moving to, or basically traversing this linked list until we get to the point that we are finding that node. Now that I find this previous node, the only thing I have to do is basically I have to tell the previous dot next that what is the value of previous dot next now, because we want to remove the last, right? So what I have to do, the last element always pointing to what? Null, right? So basically I have to tell the previous dot next it's going to be null. If it points to null, that means it's basically going to be removed automatically. That node is automatically removed from the list. And then I have to tell the last that your basically new value is going to be this previous one. Makes sense for everybody? Let's also kind of show the, I'm going to show that on the word too, but let's also clean up our code now that we know we removed something in this if else statement somewhere here. We removed an element from the list, so we need to decrement the value of size for sure. And also if you want to be also telling the user that what was the element, like what we did previously that we removed, we have to do the same thing that we did. We have a temporary element, and we know that is going to be the value of the last, because that's the last element I'm trying to remove. So I keep the element that I stored there. And then here I can give the user a message that this is an element that is removed from the linked list. So now let's just quickly back again, see how the traversing really work with this previous value. So again, we're just going to create another list. So as you can see, the last I was pointing to the null, and that's how we know this is the last. And so now, but I want to do this traversing, I need to have a temporary runner or temporary reference, and that temporary reference is going to point to the, because this is starting from the first element, so it's going to or originally have the same value as our first. So that's why we copy first into the previous. Now previous also going to be referencing to the first element. Now that we're checking the first dot next to see if that is going to be the last or not. Since it's not, then we're going to move. In order to move, I have to now pointing to this one, right? So the value of my previous no longer should be that, and so that the only way I can find it is telling this previous dot next is going to be my next, basically, right? So we'll copy the value of previous next into the preview so we can go to the next element. And now here we're checking again. Now we are here. We're checking the next of this one, and if the check of next one is last, then we'll stop. But this is not the case here, so I need to move again. In order to go another node, so I have to say that previous now is okay. It's going to be basically my previous dot next. So I keep going until I get to that location. Now here, if I say previous, that check the value of the previous dot next, you see the previous dot next is now equal to my last. So since I get location, so this is now going to be my last, and this is going no longer be in my list. That's what I want. So in order to get rid of it, nobody should point to it. So two reference we have to this last node. One of them is the last, and the other is the previous dot next. So first thing I'm going to do is to tell the previous dot next that you're going to point to the null. So basically we get rid of this link. And then I have to tell the last also that you have to point to this previous node. So that also going to be removed. So that means there is the node is still in the memory, nobody pointing to it, but the garbage collector is going to collect it. So that automatically removed from our linked list. That's exactly what we did in the code as well. So any question? Yes.
Could you mitigate that problem by having the my node also have a previous thing?
Yeah, so that's going to kind of become a different kind of linked list, right? We have if whenever we have a list to the next and the previous one, we call it double the linked list, right? We decided that from the beginning we only want to have a single linked list, right? And one of the reasons was I want to see to the order of n here, so you can see that what is going to be changed if you don't have the pointer to the previous one. But as your friend mentioned, if I already had here the pointer to the previous one, that would be also changed to order of 1, right? Because I already maintained that, so I just have to copy the value. But since this is a single linked list and we don't have that, so we need to traverse that. So that's why this one is going to be order of n instead of just 1.